Now let's turn to Los Alamos, a project on an altogether different scale from the Nazi one, a project that in scope and implications was unparalleled in scientific and technical history. Los Alamos began as practically nothing. The site itself was a small private boys' school that was seized by the incipient project, the Manhattan Project, and then people were brought in from all over the country under conditions of enormous secrecy. So many of the young physicists who went there, I think the average age was about 24, had no idea really what they were getting into. And they were quite isolated. That was on purpose, both to prevent espionage and also, in case something went wrong, to give some space for this extremely dangerous work. And as the project got going in the beginning of 1942, really, it became a hub of scientific activity. To give you an idea of the scale, by the end of World War II, the nuclear weapons industry, as it had come to be, was roughly the size of the Detroit car industry, from nothing in 1941. So this was an extraordinarily rapid expansion. The problem that they faced was this. They had to know whether this fission process would, when a neutron hit a uranium nucleus of the right kind, would it generate not only the split nucleus, but also produce enough other neutrons to continue this. Not just one neutron, but at least two, so that you would start with one, that would create another neutron, but to have an extra one that would then make this process expand exponentially. So you would go from 1 splitting to 2 to 4 to 8 to 16 to 32 to 64. And that possibility needed to be explored. How many neutrons did a fission produce? What was the likelihood that a neutron would cause a nucleus to split apart? And how far would it penetrate in the material before that happened? These became questions of absolutely the first importance. American scientists began to suggest that people not publish about this. In fact, the Germans noticed that suddenly this most exciting of all discoveries went dark in the American press. One or two people did continue. Frédéric Joliot-Curie in Paris, for instance, refused to block his research and published that the multiplication factor, one neutron would be 2.42 for uranium-235, which was promising for the continued possibility of a chain reaction. The amount of energy, as Heisenberg suspected, was clearly enormous, because the idea is really rather simple. It's that in a chemical reaction, you have an electron far from the nucleus. Most of ordinary matter is empty space, and the energy of attachment of that electron to the nucleus is what's responsible for all chemical processes, including explosions. Now, inside a nucleus, you're 10,000 times more compact than the radius from an electron to the nucleus. And more than that, you have, in the case of the uranium nucleus, not one lonely electron interacting with the core of the nucleus, but 92 protons all packed into a very small space. The combination of there being many more similarly charged particles that don't want to be together and to be that they're forced into an extremely small volume is what creates this enormous possibility for energy. If this thing could be broken in two, the two pieces of concentrated protons would fly apart with enormous energy, something like 100 million times the energy associated between an electron and a nucleus. 100 million times more energy per atom than you had in a chemical explosion. 100 million times more, for example, than TNT. What this meant, when calculated more carefully, was that a single kilogram of uranium could produce 20,000 tons of TNT. Something the size of a softball could wipe out a center city. It was thinking about these enormous energies and the possibilities that Germany might get there first that led certain key scientists, including Leo Szilard, Wigner, and others, to get Einstein to think about these questions. And Einstein, using the enormous influence that he had in virtue of being the world's most famous physicist by many orders of magnitude, then wrote a letter to the President of the United States, to President Roosevelt, and he said this: "Sir, some recent work by Enrico Fermi and Leo Szilard, which has been communicated to me in manuscript, leads me to expect that the element uranium may be turned into a new and important source of energy in the immediate future. Certain aspects of the situation which has arisen seem to call for watchfulness and, if necessary, quick action on the part of the administration. I believe, therefore, that it is my duty to bring to your attention the following facts and recommendations. In the course of the last 4 months, it has been made probable, through the work of Joliot in France, as well as Fermi and Szilard in America, that it may become possible to set up a nuclear chain reaction in a large mass of uranium, by which vast amounts of power and large quantities of new radium-like elements would be generated. Now it appears almost certain that this could be achieved in the immediate future. This new phenomenon would also lead to the construction of bombs, and it is conceivable, though much less certain, that extremely powerful bombs of a new type may thus be constructed. A single bomb of this type, carried by boat and exploded in a port, might very well destroy the whole port, together with some of the surrounding territory. However, such bombs might very well prove to be too heavy for transportation by air. The United States has only very poor ores of uranium and in moderate quantities. There is some good ore in Canada and the former Czechoslovakia, while the most important source of uranium is Belgian Congo. In view of this situation, you may think it desirable to have some permanent contact maintained between the administration and the group of physicists working on chain reactions in America. One possible way of achieving this might be for you to entrust with this task a person who has your confidence and who could perhaps serve in an unofficial capacity. This task might comprise the following: A, to approach government departments, keep them informed of further developments, and put forward recommendations for government action, giving particular attention to the problem of securing a supply of uranium ore for the United States. B, to speed up the experimental work, which at present being carried out within the limits of the budgets of university laboratories, by providing funds, if such funds be required, through contacts with private persons who are willing to make contributions for this cause, and perhaps also by obtaining the cooperation of industrial laboratories which have the necessary equipment. I understand that Germany has actually stopped the sale of uranium from the Czechoslovakian mines, which she has taken over. That she should have taken such early action might perhaps be understood on the ground that the son of the German Undersecretary of State, von Weizsäcker, is attached to the Kaiser Wilhelm Institute in Berlin, where some of the American work on uranium is now being repeated. Very truly yours, Albert Einstein. Einstein came later in his life to regret that letter, to regret having pushed America towards the first step of the building of the atomic bomb. It took much more than Einstein's letter to get that project underway, but it indicates the importance that Einstein had as someone who could intervene with the President of the United States in this fundamental matter of war and peace.